Hi everyone, I knew how much you'd miss hearing from me today, so I made this short video for you to teach you how to do structural diagrams for polyatomic ions. First, I gave you the definition here of a polyatomic ion, the group of atoms bonded together that act as a single ion. You are familiar with these whether you realize it or not. You've all probably heard of nitrates or sulfates or phosphates or carbonates at some point. The ion I have here to the left is called the perbromate ion, not as common as some of the other ones you may have heard of. Ultimately, we'll start naming and writing formulas with those, but what I want to look at right now is the structure and how they're put together. So if you look at the definition, it is a group of atoms that are bonded together. So when we look at those atoms, you'll notice bromine and oxygen are both nonmetals. So they're going to be bonded together just like the covalent compounds we've been working with. The only difference in these structures, in terms of structural formula and how we figure things out, is the fact that it has this charge right here. That charge tells me that the structure, the BrO4 together, has gained an electron. Remember, a -1 charge means there's an extra electron. So the only real difference in working with these structures is how we calculate the total pot of valence electrons that are available for bonding. So just like before, we're going to figure that number out first. Bromine has 7 valence electrons. There are 4 oxygens. Each of them have 6 valence electrons. And then I'm going to add 1 more for the charge. And I'm going to come up with my total number of electrons available for bonding. And in this case, that equals 32. So this is my total number of valence electrons. You cannot forget to do this. Add that extra electron. And remember, if it's a polyatomic ion with a +1 charge, that means you're going to subtract an electron, because a positive charge means you've lost an electron. So if it's a -2 charge, we would have added 2 electrons. If it was a -3 charge, we would have added 3 extra electrons at the end. In this case, because my charge is -1, I add 1 extra electron. From here, the process is exactly the same as before. We set up our structure. My bromine is going to go in the middle. My oxygens are going to go around the outside. I'm going to put my bonds in next. I've dealt with 2, 4, 6, 8 of my valence electrons. If I start adding my unshared electrons around the oxygens so that I end up with 8 around each oxygen, you will find at that point that I have used my 32. Once they're all on here, this is a little hard to do with my finger, so you'll have to excuse the weird look that it gives me. But once we've got that, the only other difference other than that, adding those electrons, is that we put the whole thing in a bracket and put the -1 charge outside. Those brackets help to notate that that whole structure has a -1 charge. And then you're done. Hopefully this makes sense. There is a page in your packet that I want you to work on of polyatomic ions. The substitute has a key, so you can check some of those answers as you go along, but I want you to practice a few of these. And when I get back on Wednesday, we'll go over this and any other stuff that you have questions on. If there are any problems, you can certainly message me on Schoology, and I'll get back to you as soon as I can. Hope you enjoy the rest of your day.